All right, guys, this is Mr. Goodfellow, and I know you guys don't get to hear me very often, but I'm in charge of helping you try and survive day number 5. And surviving day number 5 is going to take you on a journey that you're going to see things that you haven't seen a lot of before. Now, in the first 4 days, you guys have pretty much seen some things that you haven't seen as well before, but this time around, we're going to tackle something that's called an exponential equation. And really, the whole thing about Algebra 1 is about how are you going to actually solve for x. And I know that sounds pretty simplistic, but solving for x has been basically your main goal in all these different equations that you're solving for. The thing about the exponential one is its location of where the exponent or where the x is going to actually be. And it's in what's called an exponential location. Let me explain. So we're used to things like the 3x squared or just 2x is equal to, make them equal to 5 or to 7 or something like that. And how to solve for these, where the x is in what I would call a downstairs position. An exponential one will actually put the x in an upstairs position with a number underneath it. We're going to put it in the power location, and you're probably like, what? You're going to put it up there? How am I going to actually deal with that? Well, there's a couple of things we got to basically make sure that we're talking about with the same language. Number one, this number that's holding the x up into the air or superscripted is what's called a base. It's holding it up. It's its base of the value. This is either referred to as the power or the exponent. Okay? And if I use those words, you'll understand I'm talking about that guy upstairs. Now, how am I going to get that x to come downstairs to do kinds of stuff that we've done in the past? And that's really the whole goal. If you can get the x to come down from the superscript to be downstairs in a normal position, you pretty much got the whole equation licked. And it's really not that bad. The key to it follows a couple of simple steps that you need to follow. Number one, it says get the same base on both sides, okay? Now, this is going to be something that we really work really hard towards, is trying to get this base number that's on the bottom on either side of the equal sign to match each other. Now, to get them to match each other is sometimes you might have to use an exponent of the base, of the original base. I think that's what they want right here. So, for instance, if I say I had something that was like 4 to the x power, I could actually change it into another name for 4, which is 2 to the second power times x. So you're really changing numbers like 4s into numbers like 2s so that they can become matchers. So it's really important that you actually not only see a number like the number 4 as the number 4, but to think about it as its other kinds of powers that it could be written as. Like, hey, I see the number 8, but actually I see 2 to the third power too as well. So you're going to have to work on that kind of concept of making sure that you can change other numbers from their original base into an exponential. Now, if you can get the two bases to match, it says in step 2, cancel the bases and set the exponent part, the exponent or power part, equal to each other, and then you solve the remaining exponential, or they solve the remaining equation. Okay? Now, I'm going to make this a lot easier than that fill in the blank kind of stuff, because nobody ever talks like that. Let's kind of talk about what this really means. So it says, step 1, get the same base. Now take a look at this very first one that's listed right here, and the base is this number that's sitting down here on the bottom. And it says, get the same one. Well, happenstance, those two are exactly the same in the first place. And if they do match each other, you go to step 2, you cancel those bases. You just hack them right off like that, and they get canceled off. Now, since nothing is sitting there holding this guy back up in the air anymore, it becomes just an x minus 3 that falls down, and that's equal to a 2x minus 1 on the other side. You just equate the exponents to each other, and you solve the rest of the question. It basically means that you brought that superscript downstairs. Now, if I just do a little math here, and I do some algebra, that guy's going to go over there by subtracting x. This one's going to go over there by adding 1, and I'd end up with x is equal to -2. And that happens to be the answer for that exponential equation. So see, pretty straightforward and pretty easy. Now, the only thing that can even remotely throw at you, or we can, that would be harder is if the bases don't match each other. You're kind of like looking at this 2 and at this 8, and you're like, darn it, they don't match, and I can't cross them out. So what you have to do is think about this number 8 as 2's. You're like, how can I actually make it a 2 of some sort? Well, another name for 8 is 2 to the third power. That's 2 times 2 times 2. That's the number 8. And I can think of it as a power of 2 to the third power. And as soon as I get them to match, then that's the whole key to this whole thing. If you can get the bases to match, they cross out and the tops drop out. X equals 3. Cha-ching, I got the answer. Okay, so your goal here is get those bases to match. More than anything else, you should match those guys up. And really think about things that you already know make powers, like 9s. As soon as you see that 9, you're like, oh, that's a 3 to the second power concept. And then I've got 3 to the 3x, and I can instantly cancel the bases. 3x is equal to 2, and now I know I need to divide that 3 off on each side, and I'd get x is equal to 2/3. All right? So, big key here. Get the bases to match each other. And if you can, that kills all the problem that's really necessary there. Now, if they already match like they do in some of these, that's like a free giveaway. You're like, ooh, 7s match 7s. That's awesome. Now, you're probably thinking, what's there? There's nothing on that deal. Now, that 7 wouldn't exist unless it had a power on it, and it was 7 to the first power. When you have just any regular number, it's raised to a singular power of 1 at least. And then I can now go in and cancel those things like 7 and 7, and I have x plus 2 is going to equal 1. All right? Subtracting the 2 on both sides, and I'd end up with x equals -1. And done. There and done and done. There's your answer. Okay? Now, really look at numbers and see different things. That's something that you have to have in math too, is a little bit of vision. You're like, what is another name for 27? 27's in 3's. Well, 3 to the 4x. I don't know what I can do with there. I can't really do much. But 27 is 3 to the third power. 3 to the third. And now I've got my bases to match. And I can go with 4x equals 3. That just drops out. Divide by 4 on each side, and bam, you got yourself an answer. That's 3/4. And they can be fractional answers. They could be decimal answers. The key here is get those bases to match each other, and you should be just golden, all right? Now, if you're like willing to try a couple of questions ahead of time, practice on them on your own. Pause the video right now and then come back and see whether or not you've actually done them correctly. That's a good way to test whether or not you're doing things right. Okay? 5s are not going to be really broken down, so I'm going to leave this guy alone as x to the fourth power, or 5 to the x plus 4. And then this 125, you'd be like, man, what actually makes 125? And that would be 5. 5 times 5 is 25 times 5 is 125, or 5 to the third power, and that's what would be inside there. Cancel out those bases, and we've got x plus 4 is equal to 3. And if I subtract that, moving it over there, a little mental math, x would equal -1. All right? Start thinking that you're past that point of having to show every single item, but mental math is really something we should be forcing ourselves towards. Now, on most of these, it's only been one that's actually been changed. And like number 4, I think it's probably only going to be one still that needs to be changed. I want this guy, 16, to be in 2s. How many 2s would it take? That's 2 to the 4th. And I'm going to let you finish that guy. You're going to cancel your 2s and finish your question. 4D, 36 could probably be changed into 6s. So I've got 6 to the 1st power, because if it's not there, it's 1. And that would be 6 to the 2x. So if there is something already in the exponent, you have to multiply it there and make sure that you've got it. 6's would cancel, and you'd get 1 is equal to 2x. Again, solving, you get x is 1/2. Not a big deal. Now, on both of those last couple, it was only one thing that was changing. Now, you could actually change both sides. That's a reasonable concept. Most people would probably see this one, and I'm going to do this problem 2 different ways. One would be to just change it into 9s, and that'd be 9 to the x minus 2 is equal to 9 squared. That's another name for 81. Or somebody might see this question as 3s. And this way, going this way for 3s would mean that that one would be 3 to the 2 times x minus 2. And notice I'd put parentheses in there because that 2's got to multiply everything. And 81 would be 3 to the 4th. Now, here's the funny thing about these. Each of these 2 questions should yield exactly the same answers. X minus 2 equals 2. And if I add 2, I'd get 4. That one seemed like the easier way to do it. This one, the 3's would cancel, and you'd get 2x minus 4 with that distribution up there at the top would equal 4. And if I added that to the other side, I get 2x is equal to 8. And if I divide it by 2 on each side, check it out. It's exactly the same answer. So as long as you're consistent in making your bases match each other, you should be just fine on how they come out. So I would say go for the one that seems like the easiest variety to match. Now you have a number 5 down here. You've got number 5, 6, and 6f. Let's see what we've got here. 7s, that's 7x, is equal to 7 to the 2nd power times x plus 4. Now, this is a good example of, again, if you're going to match them up, that power has to multiply up the power that's already there. So I'd get cancellation. X would equal 2x plus 8 with the distribution. So be careful of that. And then I'd want to get my x's on the same side. So if maybe I subtract the x over here and move the 8 over there, I'd end up with x equals -8. Okay? Little mental math. Okay? Now, 16s and 8s. This is a great example of both of them need to change. Now, you're probably like, no, 16s can be 8s. No, they can't. 16 times 2 is 8, or 8 times 2 is 16. That's not going to be the way this works. You're going to have to think about how to break the 16 into a power that it can become. And I think in this case, the number 2 is the one that makes sense. 2 times 2 is 4 times 2 is 8 times 2 is 16. So it's 4th power is what that one basically needs to be. And 8 is 2 to the 3rd power, but it's times a 2x. So you're going to want to get this down to its power that it's going to be before the bases can be canceled. 4x is going to equal 6x. And this one is a strange one. If you subtracted the 4x over here, you'd get 2x is 0. And if I divided by 2, x is 0. That's the only way this guy's going to work if x happens to be 0. Okay. Now, the last one there has the same kind of concept. 9s and 27s, they need to be the same base, and I would say you probably want to think 3s. Okay, you want to think 3s to get this guy done. So this guy would be 3 to the 2nd power times x minus 2, and this would be 3 to the 3rd power for 27, and now I got my 3s to match, and then you'd go ahead and solve. 2x minus 4 with the distribution is equal to 3. Little adding of 4 over there would be 2x is equal to 7. And if I divide by 2 on each side, heck fire, you can still even get fractions as an answer to as well. All right? Now, those are all the exponential ones. We got a few down here at the bottom that look differently, but ultimately it's just the way that they're written. They say, hey, y is equal to 4 on this one and y is equal to that on that side. Well, if they're both equal to the y, then they should be equal to each other. Don't be freaked out by this statement that's listed here. It really should be written as 4 equals 2 times 3x minus 1. It's the same thing because the y's match each other. So why shouldn't the other pieces? This is 2 to the second power is equal to 2 to the 3x minus 1. And you're off to the races by canceling out the 2's and solving the rest. Okay, another 2 is equal to 3x minus 1. Add the 1, I'd end up with 3 equals 3x just by pushing that guy over there by adding. And then if I divide it by 3, I'd get x equals 1. All right? Push yourself. Make sure that your solving has become, it's starting to evolve. That's what you really want to focus on as a math student. Make sure that your skills are evolving. This funky form, 5 is equal to 125 raised to the x. I'm thinking here maybe 5s. It seems like a good deal. Try that one out. See if you can pull it off. This next door neighbor, letter H, 16 to the x is equal to 8 to the x plus 2. Thinking maybe how am I going to get those to match? Maybe 2's. 16 is 2 to the 4th and 8 is 2 to the 3rd. So make sure that you're using those appropriately. Now I'm going to pause the video. I'm going to figure out those last 2 questions. And if you get them right, pat yourself on the back. You got the idea well under control and you're ready to tackle exponentials. Get those bases to match and cancel them off. And voila, there's your 2 answers. Make sure that you're checking them. X should have turned out to be 1/3 in 7G, and it should have turned out to be 6 in 7H. Watch your math, make sure you're doing things correct, and get those bases to match. You guys have got this. This is an easy one. All right, keep working hard and keep trying on all the stuff we're doing from here all the way till June. Get the grade you want and the one that you deserve.